Now, as we start our last unit, notice we skip a topic, 4-1, and that deals with constructing counting trees where they actually do a lot of listing. So we're going to skip that, but every once in a while they give us a reference to it, and I will review it at that time so that we have the proper background to move forward. So in topic 2, we're using what is called fundamental counting principle. Now, in our system of mathematics, we use what is called base 10. We talked about this when we did logs. The common log is base 10. And what does that mean? Well, that means we have 10 symbols that we use to construct our number system. Counting numbers start off with 1, and it goes through 9. And then we get our next number, 10, by taking the 1 and then adding a 0, then the 1 and adding a 2, and so on and so forth. But keep in mind that in our fundamental counting system of base 10, there are 10 symbols. So that would be like a background item. So we'll take a look at uniformity and fundamental counting principle. We're going to study factorials, arrangement of objects, and one of your first definitions, other than base 10, is what we call uniformity criterion. Now, the word criterion just means what you're referring to in something. It's sort of like the universal set. And uniformity refers to that universal set is always the same. So if you had a set of digits, and digits could not be repeated, then if you used a digit like 5, and 5 could not be repeated, then you take that 5 out of the set. But when we use uniformity criterion, that indicates we're going to use all of the symbols. If we don't use them all and there's restrictions, then it's not uniformity criterion. And an example will work out very well for us here. So when we have a task consisting of k separate parts, then how many ways can we group those? How many ways can we count them? Well, this is the formula. The number of ways here times the number of ways here times the number of ways to the number of items that you're using in that particular example. And we'll show you an example of this. And let's start off with example 1 from our PowerPoint slides. So how many 2-digit numbers can be made from the set? And this is our set. So how many symbols do we have? 1, 2, 3, 4, 5, 6. Now, a number, for instance, if the number is 4, 04 is not a 2-digit number. We can't count the 0 in the first position. So, the strategy then for doing this is we're going to have a 2-digit number. We'll have something in that place and something in that place. Now, how many of the 6 symbols can we use in the first place? Well, we can't use a 0. There are 6 symbols, so there are 5 left. And this is what we want you to show in your notes. Now, how many can be used in the second position of a 2-digit number? Well, all 6 can now be used. So we multiply those together, and we get an answer for this is that there are 30 possible two-digit numbers that we can make up using these symbols. Keeping in mind that 04 is not a 2-digit number. And there's the answer illustrated in our text. Now, for our second PowerPoint example, be sure to indicate these example numbers in your notes. How many 2-digit numbers that do not, now you're having a restriction, contain a repeated digit? Well, again, 2-digit number, this would be your strategy. How many can go in the first position? Well, we said you can't use a 0, so there are 5 possible. And then, since one of them has already been used and you can't repeat it, you can't have a number like 55 or 44 or 33, 22 or 11. These would be repeated digits. So once you used one, because of the restriction, you can't repeat. There are only 5 choices left. So in this case, it would be 25. And there you see it. All right, example 3. How many ways can you select 2 letters followed by 3 digits for an ID? Well, for strategy of this, we set it up like so. These will be our 2 letters followed by 3 digits. So that would be like 5 places. Now, how many letters are in our alphabet? Well, there's 26 letters. And there's no restriction. And now for numbers, the digit part, we can use all 10 symbols. So a way to put this in your calculator would be like there's 2 26s, so you can go 26 to the second times 10 to the third. And you might say, what would this be? Well, we can go to our next slide and see it all worked out here. I wanted to give you the background. That would be 676,000 IDs possible as you multiply these all together. So again, we're dealing with fundamental counting principle where mathematically, instead of trying to list them all, we can pick things out. Now, a tool that the mathematicians have developed is something that are called Factorials. And what this refers to is if you have, let's say, 9 objects, and you want to get different things, then in the symbols of in this position there would be 9 that could be chosen, but then it would be 8, keeping in mind 1 fewer, then 7, then 6, then 5, 4, 3, 2, 1. That is, starting with a particular number, and then 1 less until you reach 1. This multiplication can be denoted mathematically as 9 factorial, where we use the exclamation mark following the number we're interested in. And depending on the number we have, we use the letter n. So the way to denote factorials is n factorials, where n is the number of items you're starting with. If it's 9 or 8 or whatever happens to be the case. So let's look at this more closely. This is the official formula for it, and I would write this in your notes. In fact, I believe this is already in your notes in the booklet, so you wouldn't have to write it again, but there it is. So you start off with a number, then it's 1 less, then it's 2 less, and then the ellipsis indicating it follows this pattern down to a 1. Now let's do some examples. Now there is a key in your calculator to help you with this, but this would be, if you worked it out through arithmetic, 4 times 3 times 2 times 1. This is example 4 in our PowerPoint slides. You want to include this in your notes. This is A. So 4 times 3 is 12 times 2 is 24. 4 factorial is 24. Now in letter B, we always do what's in parentheses first. 4 minus 1 is 3, so this will be 3 factorial. 3 times 2 times 1. This is going to be 6. Now in letter C, there is a protocol, a method for doing these. You can start 5 times 4 times, the remainder would be 3 factorial, and we're going to divide this by 3 factorial. Now I could have written it out 3 times 2 times 1, and this would be 3 times 2 times 1. But remember, anything divided by itself, in a sense, these cancel out, and we just get, for this, doing it arithmetically, is 20. Now again, all of this can be put into your calculator using the factorial symbol, and we want you to become familiar with that. If you don't know how to find this on your calculator, be sure to ask and I'll show you. Let's go on. And there we see it. Now, a definition you need to add is, what is 0 factorial? Well, you might think it would be 0, but in this case it's not. So this is a definition. 0 factorial is 1. So I put a little star or a box by that if you run into it in your homework. Now we're talking about arrangement of objects. When finding the total number of ways to arrange a given number of distinct objects, we can use factorial. Now, distinct means items are not repeated. So, the number of ways is n factorial. Let's look at an example now. We have a bookshelf and we have 6 books. How many different ways can you line up these 6 books? Well, if you thought about it, in the first position, there would be 6. Then in your next position, since you used one, there would only be 5. Then there would be 4. Then there would be 3. Then there would be 2. And then there would just be the one that's left. But what do you have here? You have 6 factorial. So when you go to figure this out, again, using fundamental counting principle, you get 720 is what 6 factorial is. Again, you want to include this in your notes. Now, as we go on to the last part of this, the arrangement of n objects containing lookalikes. Now, what is a lookalike? Well, you're going to see in a series of letters, if the letter is repeated, that is a lookalike. And what would the formula be? And again, it's the number of distinguishable arrangements. Because if you have an N and an N, and you switch them around, it looks the same. And the formula would be the number of items in a series. That would be n factorial. But then you divide out any number of repeats that you have. And an example will help understand this here. So let's take a look at this and see what we have. So how many letters do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we have 9 factorial. Now as we look at any repeats, we have an I, 1, 2, 3. The i's are repeated 3 times. So we have to divide it out by 3. N, there's only the one N. T, the one T. L, there are 2 L's. So our example then would be this. Now, working this out mathematically, we could sketch it out. And it would look something like this, where notice you could cancel these out. This would be the 3 factorial. And in a sense, you could cancel this 2 here with this. And then you would multiply 9 times 8 times 7 times 6 times 5 times 2. And this would give you 30,240. Or you could just put this in your calculator, click enter, and you get that. So again, you want to understand the mathematics of factorials, but also know how to use your calculator in doing this. And there we see it. Okay, we're now going into examples from our textbook, and I'm pleased to say all of these are included in your booklet. But you want to be sure you put the answers over to the right, any work that you want to show, so you can have that as a reference. So let's start to work these here. How many two-digit numbers are there in our base 10, where there are 10 symbols of counting numbers? Remember, 40 is a two-digit number, but 04 is not. So there's our first place. There's our second place. And in our first place, we can use 9. We can't use the 0 symbol. And they're not restricting anything, so in our second place, we can use 10. So this would give us a total of 90. And I have all the answers worked out for you here. Now, if you have your textbook, of course, all of this is in your textbook as well. Alright, now we want to do two-digit numbers that do not contain repeated digits. This would be a restriction. So we did some like this earlier. So in our first place, two-digit number, we can use 9 symbols. But now we can't repeat a digit, but we can use all 10. But one cannot be repeated, so we're left with 9. So this would give us 81. Now again, if you're not sure of something, you can always ask in class what was going on. And there are the results. Now, for number 3, how many ways can a club, and we don't have this result from a previous time, this was from the lesson we didn't do, can you elect a president and a secretary if no more than, you can only hold one office, and the secretary must be a man? So let me go over this with you. Now, since we have a restriction that the secretary must be a man, but I've identified the 5 people in the group, and this is the symbol for male, the symbol for female from my genetics background, and so you have 3 males. So for the, if we did the secretary first, there would be a possibility of 3. And since someone can't hold 2 positions, how many are left of the 5 individuals? 4. So 3 times 4 would be 12. And that's what they're indicating down here. Looking at example 4 now, how many non-repeating, odd, 3-digit counting numbers are there? Well, we're going to look at the book, does a nice job. It says the most restricted digit is the 3rd, again, of 3 digits, would be this 3rd place. It has to be odd. So it has to be a 1, a 3, a 5, a 7, or a 9. So they're kind of reordering this a little bit. So they're saying in this position there could only be 5. They're putting it over here, which is okay too. Now, how many symbols are left since you're using counting numbers? Well, there's only 9 symbols that you can use, since you can't use a 0. And you've used 1 in this position already. So there are 8. Now here, you've used 1 and 1. But now you can use a 0. So there are 10 symbols to choose from. It's just that because of you're using one here and another one here of the symbols you can't repeat, there are 8 left still. So this would give you then your 8 times 8 times 5, which would be 320. Now remember, we can't use a 0 in that first position, but in this second position we can use a 0. All right, let's go on. In example 5, we're going to look at counting license plates. Our textbook had a nice picture of a lot of different license plates there. So if we contain 3 letters followed by 3 digits, how many such license plates are possible? Well, we'll use the book for this one too. We'll move it down just a little so you can see the rest of it there. Okay. So 6 places in a sense. 3 with letters, 3 with the 10 possible symbols of our base 10. We get this, and again you're writing this in your booklet. You get 17,576,000 possible licenses. Now, in some cases, they may eliminate a few letters because associating them together may be not appropriate, but this is our answer. All right, let's go on to number 6. Now, a 4-digit number is to be constructed using only the digits 1, 2, and 3. How many such numbers are possible? Well, setting this up, we need 4 places here. And we're just using these. So it's be 3 times 3 times 3 times 3, which is 3 to the 4th power, which is 81 for letter A. How many of these numbers, if they were odd and less than 2,000? So again, setting it up, still going to be 4 digits, but it has to be odd. So of these, there are 2 possible odds. So there's 2 in this position. Here there are no restrictions in these positions, but it has to be less than 2,000. So our first position is going to be a 1. So 3 times 3 is 9, times 2 is 18 for letter B. So we see it illustrated here. All right, number 7, distributing golf clubs. Vern has 4 antique wood head golf clubs and wants to give to his 3 sons. How many ways can the clubs be distributed? Well, there are 4 clubs. So, again, for A, 4 clubs. And there's 3 choices for each. So 3 times 3 times 3 times 3, again, is 3 to the 4th, which is 81 different ways. Huh. How many choices are there if the power driver must go to Mark and the number 2 wood must go to either Chris or Scott? Well, since one of the clubs must go to Mark, there's only the one choice for that. And there are 4 clubs remaining and 1 is out. So that would be 3 and 3. And then for the last club, it's either Chris or Scott. There are 2 choices. So again, this one is 18. And you might say, oh, this is very much like what we did in number 6. And choices can sometimes be repeated using a similar example. Let's go on. Seating at a concert. Again, this was something they had done in an earlier section that we skipped. And they're talking about arrangements. Now, in the earlier section, they physically made up the letters, and that was kind of tedious. Here, we're going to do it using arithmetic. So here are the 4 people who were listing as A, B, C, and D, are to seat themselves in 4 adjacent seats. We made like a little picture here. But A and B are to sit side by side. So you could make this diagram, and then you're wondering how many different ways. Well, according to this chart, there are 3 different ways to seat them initially, and once they are this way, there are 2 seats left here in each of these, so that would give you 2, and then 2 other possible ways, so you get the product of 3 times 2 times 2, which gives you 12. Now, in that section we didn't cover, they show all of these ways listed. Here we're just doing and illustrating it mathematically. So you can sketch a little picture. I don't know if they have this in our book. Let me take a look here. For example, 8. No, but what I did is, in my book, I sketched a little picture of it, and then I had the values here. All right, number 9. Now, for these, I don't have the answers in the booklet, but what we'd like you to do is to be sure you use your calculator in figuring these out. So pause, try some of them, and then we'll give you the answers. Notice letter H here, 100 factorial, is such a large number, it doesn't come out on your calculator screen as a single number, but it would have 157 places. Wow. And then some of these, for letter G, 15 factorial, would have 12 places. That wouldn't show up in your calculator screen. So they're putting it in what we call scientific notation. So by these answers, or by these examples, you should include these answers. Pause. Now we did define 0 factorial as 1. Now we're going to use factorials in arranging essays in an English folder. If they have 7 essays, how many different ways can they be arranged? And sometimes these numbers are quite extraordinary. So 7 factorial is 5040. Wow. Again, be sure to include these in your notes and try them on your calculator so you have the experience of working with this symbol. Tricia is taking 13 preschoolers to the park. How many ways, if the children line up in single file, to board the van? Well, this is going to be 13 factorial. And it's, wow, 6,227,020,800 different ways. Wow. Alright, and we did some like this, but as a review, here we are looking for lookalikes, and the formula for that was how many letters? 1, 2, 3, 4, 5, 6, 7. So this would be 7 factorial. Any repeats? A is repeated, so that would be divided by 2 factorial. 3 is repeated. 3 factorial, and that would be that. And you just calculate that. And here, let's see how many symbols. 1, 2, 3, 4, 5, 6, 7, 8. 8 factorial. N is repeated twice, so 2 factorial. These would be lookalikes. I is repeated twice. G is repeated 3 times. So again, putting this into the calculator, remember it would be 8 factorial and then divided by, and then all of this in parentheses. So when we do this, we get the answer for A, 420, and for B, 1,680. And I think we've done enough on this, so this will wrap us up.